divisible. In question 1, we are asked to write 500 as a product of powers of its prime factors. So we start by dividing 500 by 2. This leaves us with 250. This is also divisible by 2, so it's 125. Now this is divisible by 5. 125 divided by 5 is 25. This is again divisible by 5, so this leaves me 5. And then again 5 to get 1. So this means that 500 can be written as 2 to the power of 2 times 5 to the power of 3. In 2a, we need to work out 1 3/5 plus 2 1/4. So 1 3/5 plus 2 1/4 can be calculated by first expressing this with a common denominator. The common denominator will be 20. So this will be 1 12 out of 20 plus 2 5 over 20. So if I add the integers, 1 plus 2 is 3, and then 12 plus 5 is 17 over 20. We are asked to give our answer as a mixed number. It's 3 and 17 over 20. In B, we need to show that 2 2/3 divided by 6 is 4 over 9. So we've got the division of fractions. 2 2/3 divided by 6. I will write 6 as 6 over 1. And I will express the first mixed number as an improper fraction. So it's 8 over 3 divided by 6 over 1. And then in division with fractions, we flip the second fraction and we turn that into multiplication. So that's going to be 8 over 3 times 1 over 6. We notice that 8 and 6 are both divisible by 2. So this leaves me a 4 and this leaves me a 3. And therefore, we're looking at 4 over 9 as required. In 3, we need to simplify 2 to the negative 5 times 2 to the 8, all raised to the power of 2, and we need to give our answer as a power of 2. So I will start by considering what I've been given, 2 to the power of 5 times 2 to the 8, all raised to the power of 2. We know that when we've got multiplication with a common base, we add the indices, so negative 5 plus 8 is 3. So this is 2 cubed raised to the power of 2. And when we've got a power raised to a power, we multiply the indices together. So this will give me 2 to the power of 6. In 4, we need to work out 0.004 times 0.32. What I could do is first focus on the actual numbers, the 4 and the 32. So 4 times 32 is 128. And we've got a total of 1, 2, 3, 4, 5 decimal places. So 3 of them will be consumed to get the decimal point here, and another 2 to get zeros there. So the answer should be 0.00128. Alternatively, I could treat this through a fraction approach. So 0.004 is 4 over 1,000, and 0.32 is 32 over 100. So 4 times 32 is 128 over 100,000, which can be written as a decimal again as 0.00128. In question 5, we've got a car factory that's making 4 different car models, A, B, C, and D, and we've got 80 people asked on their preference. The table here summarizes the results, and take into account that next year the factory will be making 40,000 cars. We are asked to work out how many of these will be Model B cars. So we start by noting that the total here is 80, and the idea is that the proportion of people who said that they would go for Model B, so 15 out of 80, would be the same proportion in the total of the 40,000 cars that will be produced next year. So we simply say that 15 over 80 should be equal to x over 40,000. This means that x is 15 times 40,000 over 80. And we start by noting that the 0 with the 0 cancel out. And then the 8 goes 5 times into 40. So 15 times 5 is 75, and the 2 zeros, so that makes 7,500 cars. In 6, we've got 3 numbers, A, B, and C, and we know the ratio of A to B is 1 to 3, and the ratio of B to C is 6 to 5. We need to work out the ratio of A to B to C, so we need to find a way of making these two statements communicate. So it makes sense to express 1 to 3 as 2 to 6, so that the 6 is common, and that will be the connecting link between the two. So that means that A to B to C is simply 2 to 6 to 5. In II, we need to express A as a fraction of the total of the three numbers. So we're simply going to use the ratios here. A corresponds to a 2, and the total is 2 plus 6 plus 5. So this is simply 2 over 13. In B, we've got Emma who writes down three numbers M, N, and P such that N is 2M and P is 5M. We need to find the ratio of M to P. So we could simply start off by saying that N over 2 is equal to M, and therefore the ratio of M to P will be N over 2 to 5N. We notice that N is common, so this cancels out, which gives a half to 5. I could multiply everything by 2, leading to 1 to 10. In 7, we've got a storage tank exerting a force of 10,000 newtons on the ground. The base of the tank in contact with the ground is a rectangle measuring 4 by 2. We need to work out the pressure. We are also being given the formula that pressure is force over area. I will start by adding the information I was given on the diagram here. So this is the area that touches on the ground, and therefore we can simply see that the pressure will be found by doing the force, which is 10,000 newtons, over the area, which is 4 times 2. Now the 4 into 100 goes 25 times, so this is 2,500 over 2, which is 1250 newtons per square meter. In 8, we've got two numbers M and N with the following properties. M is a multiple of 5, N is an even number. The highest common factor of the two is 7. We need to work out a possible value for M and a possible value for N. Now, before we actually start solving this, notice that for the examiner to be asking for a possible value for M and a possible value for N, this means that there are many possibilities for a correct answer. We're just looking for one such correct answer. So if we think about M, since it's a multiple of 5, it must be having a 5 there times other things, and N is an even number, so 2 must be a factor of this. In addition, the highest common factor of the two is 7, so both of them must have a 7 and no other common factors, and therefore I could pretty much fill after this anything I want, provided I don't change the fact that the highest common factor of the two is 7. So I could simply say here times 1 for both, leading to M being 35 and N being 14. And therefore one possible value for M is 35 and a possible value for N is 14. In 9a, we need to complete the table of values for y is 6x minus x cubed, shown here. So we start with x being negative 2. So this means that y is 6 times negative 2 minus negative 2 cubed, which is minus 12 minus negative 8. So that's minus 12 plus 8, which is negative 4. Now for negative 1, it's going to be 6 times negative 1 minus negative 1 cubed, which is minus 6 minus negative 1. That's negative 6 plus 1, which is negative 5. For 0, it's easy to see that when x is 0, y is 0. And for 1, we've got that y is 6 times 1 minus 1 cubed, which is 6 minus 1, which is 5. We can then proceed in drawing the graph for this curve for values of x between negative 3 and 3. We start by plotting the points from the table, and we join them with a smooth curve. It's a cubic curve with the equation y is 6x minus x cubed. In 10, we've got Lina who spins a bias 5-sided spinner 40 times. The results are summarized here. and she's now gonna spin the spinner another 2 times. We need to work out an estimate for the probability that she gets a score of 5 both times. So we know that the total here is 40, so the probability of getting a 5 is 10 out of 40. We want the 5 both times, so 2 consecutive times, so 10 over 40 times 10 over 40. Obviously the 10 over 40 is simply a quarter, so a quarter times a quarter is 1 over 16. In B, we've got Derek who's gonna spin the spinner a large number of times, and we need to work out an estimate for the percentage of times Derek can expect to get a score of 1. So going back to the table, we see that 6 out of 40 is the probability of getting a 1. So we need to convert that into a percentage. We can simply say that 6 over 40 is equal to x over 100. So x will be given by 6 times 100 over 40. I could start by simplifying out the 0 with the 0 here. This leads to 60 over 4, which is of course 15%. In question 11, we're given here the trapezia Q and P, and we are told to describe fully the single transformation that maps P onto Q. So the first thing to do is realize that we're dealing with an enlargement because the size has changed, and we can draw a series of rays passing through corresponding vertices in order to identify the center of the enlargement. So let's start by drawing these lines 1, 2, 3, 4. We can see that they all meet here at the point 0, 2. So that's the center of the enlargement. And then we can proceed in finding the scale factor. So we can measure corresponding distances on the object and the image. On P, this distance here is 3, and the corresponding distance on Q here is just 1. So let's remind ourselves that the scale factor is simply the image over the object, which in our case will be 1 over 3 because Q is the image and P is the object. The object is the original, the image is the final thing, so it's 1 over 3, and therefore we can conclude that we're dealing with an enlargement with scale factor a third and center 0, 2. In 12, we are asked to solve the simultaneous equations given here, and I will be using elimination here. I noticed that I could start by multiplying the first equation here by 3. So if I multiply everything by 3, this leads to 15x plus 6y is equal to 33. And if I multiply the second equation here by 2, I'm getting that 8x plus 6y is equal to 12. And now I've got the same number of y's in both equations, so I could deduct one from the other. 15x minus 8x is 7x. The y's go away. 33 minus 12 is 21. So x is equal to 3. And I still need to proceed in finding the value of y. I could substitute maybe in the first one here. 5 times x, which is 3, plus 2y is equal to 11. So 15 plus 2y is 11, which leads to 2y being negative 4, and therefore y is negative 2. In 13, we are told that p is inversely proportional to t. Well, if two variables are in inverse proportion, it means that their product is always the same. So I've got a pair of values here. T is 100, p is 1. 100 times 1 is obviously 100. So in all cases, I should be getting a product of 100. So I could use that in order to find the missing values. 25 times 4 is 100. 20 times 5 is 100, and 2 times 50 is 100. In 14, we're given in the table here the weight in grams of some potatoes. Obviously, it's a grouped frequency table. We've got the first class going from 50 to 70, then 70 to 20, and so on. And we need to draw a histogram for this information. Now, in the vertical axis of the histogram, it's the frequency density. And let's start by reminding ourselves that the frequency density is simply the frequency divided by the class width. So I could actually draw up a table here. It's the class width and the frequency density. So the class width for the first class is 20 because 70 minus 50 is 20. Then it's 10. then it's 10, and then again 20. So to find the frequency density, I'll be doing the frequency 20 divided by the width. So 20 over 20 is 1. Then it's gonna be 50 divided by 10, which is 5. Then it's gonna be 60 divided by 10, which is 6, and then 30 divided by 20, which is 1.5. So we need to draw up the histogram now. I will start by scaling my vertical axis. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. And I only need to draw my bars. So this is my histogram here. The first class goes from 50 to 70, having a frequency density of 1, and so on for the rest. So the horizontal axis is the weight in grams, and the vertical axis is the frequency density, which we calculated by doing frequency over class width. In 15, we've got a sector of a circle having a radius of 18. The angle of the sector is x degrees, and we are told that the length of the arc here is 4 pi centimeters. We need to work out the value of x. Well, we start by noting that the length of the arc is simply x over 360, so the angle over the 360, which corresponds to a full revolution, times 2 pi r, and in our case it's 18, the radius, and this should be giving me an answer of 4 pi. Now we have some simplifications. The pi will cancel out, the 360 with the 18 cancel out to leave me a 20 here, and then the 20 with the 2 leaves a 10 here. So we've got that x over 10 is equal to 4, and therefore x must be 40 degrees. In 16, we need to prove the following identity here. 2m plus 1 all squared minus 2n minus 1 all squared can be written in this factorized form. So one way to do this is start from the left. So we've got 2m plus 1 all squared minus 2n minus 1 squared. This means it's 2m plus 1 times 2m plus 1 minus 2n minus 1, 2n minus 1. I will carefully expand everything here. I get 4m squared plus 2m plus 2m plus 1 minus brackets 4n squared minus 2n plus 1. This leads to 4m squared plus 4m plus 1 minus 4n squared plus 2n minus 1. Notice that the plus 1 with the minus 1 will cancel out, and I'm left with 4m squared minus 4n squared plus 4m plus 4n. Now we'll consider these in pairs. So the first pair is the 4m squared minus 4n squared, which has a common factor of 4, brackets m squared minus n squared. And the second pair is the 4m plus 4n, which also has a common factor of 4. So 4 brackets m plus n. Now the m squared minus n squared is a difference of two squares. So factorizing to m minus n, m plus n, plus 4 brackets m plus n. And we notice here that the 4 is a common factor, but also the m plus n is a common factor. So I can take this out, 4 brackets m plus n, close brackets, another set of brackets, it's the m minus n plus 1. The 1 is because all of this has factored out, and I'm left with just a 1 here, which is exactly what I was asked to show. Now this may seem like a long way, but it's the safest way, I could say, because I have expanded carefully and got exactly the right hand side. Alternatively, we could notice that the original expression on the left hand side is the difference of two squares. So this is an alternative approach. We've got 2m plus 1 squared minus 2n minus 1 squared, which can be written as 2m plus 1 minus 2n minus 1. That's the first bracket, and the second bracket will be 2m plus 1 plus 2n minus 1. Notice that here the plus 1 with the minus 1 will cancel out, so I'm left with 2m plus 1 minus 2n plus 1 in the first bracket, bracket 2m plus 2n. So this is 2m minus 2n plus 2 times 2m plus 2n. Now there's a common factor of 2 in the first set of brackets, so if I take the 2 out, I'm left with 2 brackets m minus n plus 1, and also a common factor of 2 on the second set of brackets here, and these will be 2 brackets m plus n. So 2 times 2 is 4, so this will be 4 brackets m plus n brackets m minus n plus 1, which is exactly the right hand side once more. We are then told that Sophia says that the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4, and we are asked on whether Sophia is correct, giving reasons for our answer. Well, if we look at the original expression, it was 2m plus 1 and 2n minus 1 all squared. That was the difference of two squares, and actually 2m plus 1 has to be an odd integer and 2n minus 1 is another odd integer, because all odd integers are one more or one less than an even number, and 2m and 2n are surely even, and therefore we simply say that yes, Sophia is correct, since any odd number can be written in the form of 2m plus 1 or 2n minus 1, and we have shown above that 4 is a common factor. 4 is a common factor always, which means that the difference of the squares of any two odd numbers must be a multiple of 4. In 17, we are asked to work out the value of 8 over 27 to the power of 4 over 3. So we've got 8 over 27, it's a fractional power, 4 over 3. So this can be written as the third root of 8 over 27 raised to the power of 4. Remember that when we've got a fractional power like this case, the denominator becomes the root here. So the third root of 8 is 2 and the third root of 27 is 3. So we're looking at 2 over 3 to the power of 4. Now 2 to the power of 4 is 16 and 3 to the power of 4 is 81, and therefore the final answer is 16 over 81. In 18, we're given A and B points on the circle centered at O. The angle AOB is x degrees. DBC is a tangent at B, and we need to show that ABC here is a half x. We need to provide reasons because we are constructing a proof here. I start by noting that OB and OA are equal in length because they are both radii, and therefore the triangle OAB is an isosceles triangle. So the angle here is the angle at the base of an isosceles triangle, and this means that this here is simply 180 minus x divided by 2. So we start off by stating that angle OBA is equal to 180 minus x over 2. This simplifies to 90 minus x over 2, and we need to provide reasons. A rule of thumb says that for every new number that appears, we need to provide a reason. And we've got the 180 appearing here, and that's because the angles in a triangle add up to 180 degrees. And the over 2, it's because angles at the base of an isosceles triangle are equal. We then note that the angle OBC here, it's the angle between the radius and the tangent. It's a 90-degree angle, and therefore we can state that OBC is 90 degrees. And the reason is that the angle between a tangent and the radius at the point of contact is 90 degrees. And therefore we conclude that the angle we're trying to find, the angle ABC, is simply the right angle 90 minus the angle OBA. So we therefore say that ABC is equal to 90 minus the 90 minus x over 2, which is 90 minus 90 plus x over 2, which of course gives me the x over 2 as required. Now an alternative approach would be for me to add an extra point here on the circumference and join A with this new point and then the new point with B, so it will look something like this. We could label this point E, and we notice that x is the angle at the center, so this angle at the circumference should be half of that. So we have that BEA is x over 2. So we write that BEA is x over 2. And the reason here is that angle at the center is twice the angle at the circumference. And then we notice that since this is the x over 2 and this here is the chord connecting with the tangent, we've got alternate segment theorem, and therefore we can simply say that ABC is equal to x over 2, and the justification here would be the alternate segment theorem. In 19, we are asked to solve the given equation here, and we need to give our answer in the form of a plus minus b root 2, where a and b are fractions. Now, just looking at the form of the final answer, this hints at the quadratic formula. So we're dealing with an algebraic equation that involves fraction. It's 1 over x minus 1 over x plus 1 is equal to 4. I will start by writing the 4 as 4 over 1. And I identify the LCM as being x plus 1. I'm trying to eliminate the denominators. So the first fraction is to be multiplied by x plus 1, the second one by x, and the 4 by x plus 1. And this leads to x plus 1 minus x is 4x plus 1. The left-hand side is simply 1, and the right-hand side is 4x squared plus 4x. I will be collecting everything on the right-hand side. To get 0 is 4x squared plus 4x minus 1. And I'm looking at a quadratic with a being 4, b being 4, and c being negative 1. So I'll be using the quadratic formula here. We have that x is minus b plus minus b squared minus 4ac square root of this, and all of it over 2a. So this simplifies to minus 4 plus minus 16 plus 16 square root over 8. So we can proceed into looking at minus 4 plus minus the square root of 32 over 8, and we can write the root of 32 as root 16 root 2. So this will help me approach the form of the answer which involves a root 2. So we're now looking at minus 4 over 8 plus minus 4 root 2 over 8, which of course simplifies to minus a half plus minus a half root 2. In 20, we've got Alfie, who has 11 cards. 3 of them are blue, 7 are green, and 1 is white. He takes at random 2 of these cards, and we need to work out the probability that he takes cards of different colors. So one way of approaching this is by considering all possible scenarios that will lead to 2 cards of different colors. So if we think about it, we've got the blue-green scenario, the green-blue, then blue-white, white-blue, and then green-white and white-green. We've got a total of 11 cards. So for a blue-green scenario, it's going to be 3 over 11 times 7 over 10, because the 11 becomes a 10 due to the fact that one of the cards has been removed. And this leads to 21 over 110. For the green-blue scenario, it's going to be 7 over 11 times 3 over 10, which leads also to 21 over 110. Moving on to the blue-white scenario, we've got 3 over 11 times 1 over 10, and this gives 3 over 110. And for the white-blue, it's going to be 1 over 11 times 3 over 10, which is also 3 over 110. And finally, for the green-white scenario, it's going to be 7 over 11 times 1 over 10, which is 7 over 110. And 1 over 11 times 7 over 10 for the white-green scenario, which gives 7 over 110. If I add all of this up, I should be getting the probability I was asked to find. We can see that 21 and 21 is 42 over 110. then 3 and 3 it's another 6, and then 7 and 7 it's another 14 over 110, and therefore 6 and 14 it's 20, and 42 it's gonna be 62 over 110, which of course simplifies to 31 over 55. Now, an alternative approach would be to consider the complement of what we are trying to find. Remember, we were asked to find the probability of taking cards of different colors. So one could say that this is 1 minus the probability we get same colored cards. So this will be 1 minus the probability we either get a blue or a green scenario. The white scenario cannot happen because we've got only one white card, so there is no chance we get two white cards. So for the blue scenario, it's gonna be 3 over 11 times 2 over 10, and for the green scenario, it's gonna be 7 over 11 times 6 over 10. This leads to 1 minus 6 over 110 plus 42 over 110, which is equal to 1 minus 48 over 110, which is 62 over 110, which simplifies to 31 over 55, and therefore agreeing with the original approach shown above. In 21, we've got a sketch of the curve y is cos x, and we need to find the coordinates of P, which is a minimum point. Now for the cosine wave, we know that at 90 degrees we cut the x-axis, and then at 270 we also cut the x-axis, and the minimum point is actually halfway through the two cuts, so it's at 180, and the y value is -1 because the cosine of 180 is -1. Remember that the cosine wave oscillates between -1 and 1. In 22, we've got triangle ABC here, and we need to work out the value of sine of ABC. It's the angle here. I will be using the sine rule here. We've got that the sine of ABC over the length of AC, the length here, 6.5, is equal to the sine of 30, which is the angle A, over the 10.7. Now I will solve for sine ABC. So sine of ABC is equal to 6.5 times sine of 30 over 10.7. Remember, we are trying to get an answer in the form m over n, where m and n are integers. So what I will be doing, I will be writing 6.5 as 65 and 10.7 as 107. So 65 sine 30 over 107. Now we know that sine of 30 is a half. So 65 times a half of 107, which can be thought of as 65 over 107 times 1 over 2. And therefore we multiply 65 by 1 to get 65, and 107 times 2 to get 214. So sine of ABC is 65 over 214. In 23, we've got the first 5 terms of a geometric sequence, and we need to work out the next term of the sequence. So we need to figure out what will go here. Now remember that in a geometric sequence, we multiply by the same amount to get to the next term. And looking at the terms, I noticed something interesting. The odd terms have a factor of √5, whereas the even terms do not. So I noticed that to go from the first to the third term, I multiply by 20. From the second to the fourth, I multiply by 20. And so from the fourth to the sixth term, which is what we're trying to find, I will multiply by 20. So all we need to do is 200 times 20, which gives you an answer of 4,000. And then in part B, we are told that the fourth term of a different geometric sequence is 5 √2 over 4, and the sixth term is 5 √2 over 8. And we need to work out the first term of this sequence. Well, it makes sense to draw a diagram here to illustrate what's happening. We are given here 6 positions, so this is 1, 2, 3, 4, 5, 6. These are the first 6 terms of the sequence. The sixth term is 5 root 2 over 8, and the fourth term is 5 root 2 over 4. Remember, we're trying to find what will go here, the first term of the sequence. So to start off with, I can figure out how to go from the fourth term to the sixth term. So if we just do 5 root 2 over 8 divided by 5 root 2 over 4, this is simply 5 root 2 over 8 times, I'm flipping the second fraction, 4 over 5 root 2. The 5 root 2 will cancel out. The 4 over 8 will leave 1 and 2 in the denominator. So this is simply a half, which means that to go from the fourth to the sixth term, we multiplied by a half. This means that I could now look at the whole process in a reverse way. So to go from the fourth to the sixth term, I multiply by half. So to go from the sixth to the fourth, I multiply by 2. And then to go from the fourth to the second, I also multiply by 2. Remember, we're trying to get here. So this times 2, which covers 2 jumps here, I can split it into a times root 2 times root 2 as shown here. So to go from the second term to the first term, I will simply be multiplying by root 2, which means that to find the first term, I'll be taking 5 root 2 over 4 times 2 times root 2. So 5 root 2 over 4 times 2 times root 2. The 2 with the 4 cancel out, leaving me with the 2 in the denominator. Root 2 times root 2 is 2, so it's 5 times 2 over 2, which of course simplifies to 5. In 24, we've got a sphere and a cone as shown, and we are told that the volume of the sphere is equal to the volume of the cone, and we need to work out the ratio of R to H. So we start by equating the two volumes. So 4 over 3 pi r cubed is equal to a third pi r squared h. We notice that we're dealing with some simplifications here. The pi with the pi, they cancel out. The over 3 with the over 3 cancels out. And I'm left with 4r cubed is r squared h. I can now proceed into simplifying the r squared with the r cubed to leave me with an r here. And therefore we have that 4r is equal to h. And therefore r over h is equal to 1 over 4. This means that the ratio of R to H is simply 1 to 4. In part B, we've got a different solid sphere and a different solid cone, and we are told that the surface area of the sphere is equal to the total surface area of the cone, and we need to work out the ratio of R to H. Remember that H is the height of the cone as shown here. I immediately spot the right angle triangle here, so it helps noting down that h squared plus r squared is equal to L squared, Pythagoras theorem here. So let's start off by working on the fact that the surface area of the sphere is equal to the total surface area of the cone, and therefore we have that 4 pi r squared, the total surface area of the sphere, is equal to the total surface area of the cone, which is the curved surface area pi rl plus pi r squared, which is the base of the cone. It's just a circle. This means that we end up with 3 pi r squared is equal to pi rl, and therefore I can simplify the pi with the pi and the r squared with r, leaving me with r on the left hand side. So we've got that 3r is equal to L, and therefore if I square everything, I get that 9r squared is L squared. So using the Pythagoras theorem that we have applied here in the cone, h squared plus r squared is L squared, we can substitute L squared with 9r squared. So h squared plus r squared is 9r squared, which leads to h squared is 8r squared, and therefore I can take square roots to get that h is root 8 times r, and therefore 1 over root 8 is equal to r over h, and therefore the ratio of r to h is 1 to root 8.